Hello and welcome to a brand new video series of embryology, and in this series we're going to focus on the first 4 weeks, and so this particular video in that series is going to go from fertilization to the formation of a blastocyst, and we are going to discuss implantation. So what we want to make sure we look at is we will see how the embryo develops from a fertilized egg. So we need to talk about a zygote, a process called cleavage, the formation of a morula, and the blastula. Then we'll look at how the blastocyst forms. We'll be looking at things like the trophoblast, the inner cell mass, and then eventually a formation of what is called a bilaminar disk, and that will be what's going to undergo the next stages that we'll discuss in the next video with gastrulation. Then we're going to look at how we implant and a little bit of the early extraembryonic membranes, what will become chorion, allantois, yolk sac, amnion. So we'll need to have those for later videos. So what we want to get started with, of course, is where it all began. And this is going to begin with unison of two cells. Once a month, a female ovulates, and she produces a single cell called an oocyte that has gone through various levels of development. And inside this oocyte, there will be a nucleus containing half her DNA, a complement of her DNA, as well as her partner will produce spermatocytes, and the spermatocytes will carry cells that the cells will carry nuclei that have the genetics of the father, have his DNA. And surrounding this from a fate of ovulation is a series of cells that act as a barrier to fertilization called the zona pellucida. Now this will come in handy and important later, the zona pellucida, when the egg hatches, so to speak. So what has to happen is all of these spermatocytes that are produced by the male, there are millions upon millions, and they have in their heads a cap of enzyme called the acrosome, and the acrosomal reactions have to occur to break through this. So as many of them attempt to break through, one will and be brought in. There is kind of a folding and infolding here that happens, and eventually what is going to occur is the nucleus of this cell and the nucleus of the sperm and the nucleus of the oocyte will form together, having a diploid cell, a cell with 2 copies of every chromosome, and then once it is fertilized, we can refer to this cell as a zygote. And zygotes, being a diploid cell, having 2 copies of every chromosome, one from the mother, one from the father, resulting in a diploid cell, the zygote. So this zygote, what happens is this process of fertilization is going to occur somewhere about 2 weeks after menstruation. Usually after a woman's menstrual cycle begins, she has about 7 days there, 7 days post. In a typical idealized cycle, day 14, she ovulates, and somewhere about that time period, this is when it approximately occurs. Now this is associated to an idealized cycle. We know that there are always alterations to that, so this is why we'll say approximately or about for an idealized cycle that this occurs. Now what we want to do is after we have ovulation has occurred, and this occurs, so we're starting off basically day 1 of development is counting down. So we have day 0 is the ovulation event, and that oocyte was released, and by that 14th day fertilization happened in an idealized cycle. We're now going to see that it took about a day after this occurred for fertilization to happen. And the sperm can live for quite some time, several days inside the uterine tubes. So if reproduction occurred a little early, this will still be able to fertilize and forming a zygote if it happens. So this was basically all occurring from day 0 to day 1, day 0 to day 1. Of our cycle. So now we're going to go look at day 2. Day 2 has a lot more going on. Very important day is day 2. Lots and lots of things happening. So our zygote here that we have during day 2, we said was diploid. It had 2 copies of every chromosome, 2N, and this is a zygote. So to make sure that I can do this properly, what I want to do is look at change my pen size a little bit here, and this 2N zygote, and the zygote being a diploid cell will be able to undergo some divisions. It will begin a process called cleavage, and what cleavage is, it cleaves. This is a division. The cells will divide in half as the cell undergoes mitosis, and you have what is called a cleavage furrow there. And as it divides, the 2 cells will undergo a 4-cell stage. Now these cells, they like to stack over each other because of the type of cleavage that human beings have. And then lastly we'll go, so we had 2 cells, we have 4 cells, and then we'll 1, 2, 3, 4, 5, 6, 7, 8. We have an 8-cell mass. Now here we have something very interesting that happens. We have an 8-cell mass of cells called blastomeres. Each one of these is referred to as a blastomere. And the blastomeres, they all have a very interesting type of cleavage called indeterminate cleavage. Every one of these cells are indeterminate. And what does that mean, that they're indeterminate? That means that if I take by the time we get, until it reaches 8-cell mass, if I take one of these cells here, that can become a whole person, a whole new individual, an identical twin. After that goes from your 8-cell stage, it can no longer do this. It loses its ability. So now there's other ways that twins can happen, but twins, they can go anytime until 12 days of gestation. After 12 days of pregnancy, twinning can no longer happen. But our 8-cell mass there, it divides, and it's dividing and dividing and producing cells that are much smaller. So between day 2 to day 5, there's a whole lot of divisions occurring between day 2 to day 5 that is going to occur, where cells are going to divide a whole lot. Now we are discussing here, guys, the first 4, so just letting you know that day 2 through day 5 has got a lot of divisions. The cells are going to divide much smaller cells. We're going to produce lots of small cells, and these smaller cells that are being produced are going to produce a solid mass, a solid ball, completely filled with smaller cells called a morula. And these morulal cells, what they're going to do is they're going to have some cell junctions that are going to form in, and these cell junctions are starting to hold this cell together, hold every one of these tiny little cells as the cells get smaller, and they're held together through these type of cell junctions called tight junctions, these being tight junctions. You have a process called compaction. And compaction is where these cells get smaller, they'll get smaller, and they will form tight junctions. So this would have our morula is undergoing compaction. And and compaction here, these individual blastomeres getting smaller, forming this into a nice morula, a tight little morula. So first 4 weeks, as we're looking at, we're going to be in this day 2 to day 5. Remember, there'll be a lot of cell divisions here, and we're looking at 4 weeks. Now, day 5, by day 5, at the end of this, when we get into day 5, there's going to be a lot more interesting things happening. Your cells in the middle are going to pre-program to die. They're going to undergo a programmed cell death in the center. So your individual blastomeres, there will be if we were to cross-section this, if we were to cut open a ball, so imagine that I have a ball, and that ball on the outside is a solid coating of cells, and I were to take and cut across it and look into it, I would see this cross-section of cells. And I have these outer cells here, which are going to be called the trophoblast. And the trophoblastic cell is going to be important because that's what's going to be involved in implantation. And then our inner cavity here, called a blastocyst. And the blastocyst inner cavity, or sometimes called blastocyst cavity, is going to ultimately become body cavity, things like that. Your gut, thoracic cavity, the internal structures of your body. Now, these structures that is important for the trophoblast is ultimately going to go on to help form things like the placenta. So this is going to help form placenta, part of the placenta, the embryonic side of the placenta, many other structures that are going to be important for that, some of the other cell membranes, some of the other extraembryonic membranes. So that's also going to be very important. Now, what's eventually going to occur is these cells inside, there's going to be a cluster inside this blastocyst of cells that they're going to be communicating, and they're going to use some cell junctions called gap junctions, and they're going to use gap junctions and communicate and differentiate, and we're going to see that now, and they're going to form something called an inner cell mass. So what we want to do is draw our trophoblasts, our outer mass of cells, as these cells form a ring with a blastocyst. And we have our blastocyst inside, and there's going to be a series of cells inside here, and they're going to get connected using cell junctions called gap junctions. So here we have gap junctions. Now, gap junctions are very important for communication from cell to cell, direct signaling. So this is an important special place where that happens. Also, we know it's important in the heart cells. And these cells here called inner cell mass cells, the inner cell mass. Now these are important, inner cell mass. The inner cell mass can become literally pretty much virtually all tissues in your body. Now they can't become a unique individual, though they become almost any tissue, because at this point these cells won't be able to form a placenta. So that's why after you can have other kinds of twins, but by day 12 you're not going to be able to, day 12 of gestation, but these cells can become any tissues. These are the so-called embryonic stem cells that we hear in the news, etc. These are the stem cells that people want to try to do stem cell therapy, the inner mass cells, and these guys have not been predisposed to become something yet. They can become any kind of tissues pretty much. These are the embryonic stem cells of the inner cell mass found in your blastocyst cavity or the blastocyst. So we'll make sure we have blastocyst right here. So this blastocyst has your trophoblast. We want to make sure we have that so we know what we're looking at. Your trophoblast, your blastocyst, and your inner cell mass. Now, some other very interesting things are going to happen here. We're not going to draw it because it could be a little bit difficult to do, but that's more looking at days 6 through 7. So we were at day 5 still here, so let's write that out that we know this is day 5. Days 6 and 7, I want to talk about a little bit is day 6 and 7. There is a hatching from the zona pellucida. So this is where you hatch. Basically, the zona pellucida, this membrane around, it hatches. And what it's going to basically do, I'll kind of show you here, it's easier to do it here, to redraw that, we can draw it out this way, is and I haven't been drawing the zona pellucida, but your trophoblast here is surrounded by that zona pellucida still. And that zona pellucida needs to go away. It needs to be removed. And so in this hatching, as it removes, you're going to be able to expose the trophoblast cells here. Here I said I wouldn't draw it. A little impromptu there. And these are going to be exposing the trophoblast cells. And remember, those inner cell mast cells are here too. So, but it's this exposure of the trophoblast that's very important, because this must be done to allow for implantation. If conditions are favorable, implantation can occur. And to understand implantation and that conditions are fine, we have to kind of understand what's going on there. So if I were to have a uterine cavity here, this being uterine cavity, there will be a set of cells of the uterine cavity here. And this is your uterine epithelium. This is the lining here. So let's just write, this is a cavity. This is area that's in the uterus, uterine cavity. And so this is a hollow spot. And inside here, there will be glands called uterine glands, and they will emerge to the surface. They are incredibly important on providing nutrients prior to implantation. These are going to be the ones that are going to give all the nutrients to your blastocyst. As it's floating in the uterine cavity, it's going to secrete nutrient-rich fluid. Now, the other thing that you're going to have with it is a spiral of arteries called the spiral arteries that are going to be there as well. And these spiral arteries that are present, they change with their prevalence with the uterine cycle. That's what's responsible for the dying off of the uterine tissues, is when these constrict and die off, that will allow the sloughing of the functional zone of the uterus, and then these reappear due to estrogen progesterone. And these being uterine glands, these are the two big deals for what is going to allow for implantation to occur if conditions are perfect, conditions are favorable. And then here we have our uterine epithelium. And the newly hatched, quotation mark, blastocyst can then come in and adhere, because it is no longer covered by a zona pellucida, can adhere to this uterine epithelium. And let's make sure we have the inner cell mass in there. We want to know that it's there. And it will fuse to this and begin to implant. And as it implants, the uterine glands, they're going to, as they extend here, and the spiral arteries supplying all the nutrients early on, eventually umbilical cords going to form, things like that. But this is the process of implantation and how that happens. So implantation can occur after the hatching on day 6 to 7 from the zona pellucida, exposing the trophoblast surface so it can actually bind to uterine epithelium. Apologize for the crudeness of some of my drawing here. Now, to really kind of get a better idea of this, because we need really to be able to become parts of the placenta, the trophoblast, the inner cell mass, and to understand what's going on, this implantation, it occurs during the secretory phase of your uterine cycle. And secretory phase occurs after day 14, after ovulation has occurred, so this is a big part of that. So if you were to look at an idealized cycle here, and I were to sketch out idealized cycle, we're going to be dealing with day 0, day 28, day 7, day 14, then this is going to be right around that day 14. Secretory phase is right here after day 14. Menses, proliferation, and secretory phases of the uterine cycle. Now, these blastocysts, their inner cell and the trophoblast, these help become part of the placenta, the blastocyst, and the blastocyst is going to become your yolk sac. So right here, we're going to become yolk sac. That is where your first blood cells will come from. And the cavity also will help become part of your digestive tract, your thoracic cavity, things like that. So what we want to go on now is look at the uterus and its structure. And to kind of get an idea of the uterus, we want to kind of draw a histological uterus here. So we're going to draw what kind of looks like a little cup. And there are going to be 3 layers to it. One is the thickest layer. We're going to draw lots of lines here. I'm going to try to draw them as neat as I can. This is your muscular layer. This is the myometrium. This will be a very important one. I will label these, so don't worry. And then we're going to have another layer here, and then one more layer. Now, the thing is that is important is your uterine cavity is not much in terms of thickness. It is a very thin uterine cavity. So that is uterine cavity there. Normally, it is a very small space. Now, the cavities that we have here, and the layers, we're going to start off with the endometrium. Now, the endometrium is consisting of this layer and this layer together. So all of this stuff here and all this stuff here, okay, is our endometrium. Endometrium. This area here is the myometrium. This is what causes the contractions. And then out here is the serosa, the peritoneal layer of it called the perimetrium. And now of this, right now, the endometrial lining is the most important. The lumen or cavity of the uterus, as you can see, is a very small cavity. But we have these 2 layers that I have used different colors for. And this layer right here, and I want to color him in a little bit, color her in, and make sure we could see this distinctive layer here in a lighter blue. This layer here is the very important functional zone. I'm going to abbreviate it F. Whereas the more standard darker blue here that would be found in here, and let's color that in a little bit. And sorry for my crudeness, it's very hard to draw on the iPad here. You would have the basilar zone. Now, it's the functional zone that is sloughed off and lost during menstruation. So during the, this, if you would have a thick functional zone, this is during the progesteronic or secretory phase from about day 14 to about day 21 that you would see this, where the basal layer may have more stromal tissues in the bases of those glands, but the functional layer, who's very lighter in coloration, it's coiled uterine glands. This is where the implantation happens. So the blastocyst is going to be able to implant on the functional layer, and so it's very important that that functional layer is thickened during the progesteronic or secretory phase. So this would be a uterus and secretory phase, so that uterine layer would look like this during secretory, very vascularized with extensive uterine glands neurons that extend all the way to the surface. Now, the last thing we are going to discuss today is the extraembryonic membrane formation and look a little bit at the bilaminar disc. So we're going to discuss some very complicated terms and some important drawings going on the uterine membrane. So what we want to do is, in our drawing, we're going to look at the base right here, the base of our uterus, and our uterine spiral arteries coming down from the base there, and our glands, uterine glands coming down. Now what we want to do is come down here, and I'm going to make my pen a little smaller, and I'm going to wrap my uterine epithelium like this, and we're kind of stop it here, and we're going to wrap it like this, and we're going to have a gap in there. We're going to have this opened up a little bit. And when we do that, we're going to draw a bunch of little ovals here and connect all these guys together. So bear with me. We want to draw it first so I can discuss what everything is. And take all these little cells here and connect them here. And also, we want to discuss our little cavity here. So now we want to take red, and we're going to draw a circle here. And on this outer part, I'm going to shade all this in red. So just bear with me. Just follow me on the drawing first. Then we'll come in and label things and discuss what they are. But we want to put some red here. Now, if you're drawing with pen and paper, it's easier to draw that. Now, on the inside of this cavity, we're just going to take and draw some little ovals on the inside lining. And then I'm going to take orange circles and go across like this. And then I'm going to use red and use a small pen, and I'm going to draw some little columns. Okay, so, and on top of that, let's pick, I'm going to use brown. I'm going to pick the shade of brown I want to use here. We'll use that. And I'm going to use kind of a shade of brown, and I'm going to come up over this with a mass of stuff, mass of tissue that we're going to label in a minute, and shade that in. So what are we looking at here? What is all this mess that we just looked at? First off, let's make sure we know that we have our uterine cavity. This is the uterine epithelium. I'm just going to abbreviate it UE now since we talked about it. What we want to discuss is these cells here. These are the Syncytial Trophoblast cells, Syncytial Trophoblast cells, single nucleate cells that surround this. So this is the trophoblast, what it grew up to kind of be. We're going to put one dot in each one of them because they are single nucleated. And there's another set of cells that have many nuclei in it that we have just drawn that we want to label. And they are these cells here, called the Syncytial Trophoblast. Syncytial Trophoblast. Let me start that correctly there. So this would be the Syncytial Trophoblast cells. Now these Syncytial Trophoblast cells are multinucleated, many nuclei, and they are peripheral to the cytotrophoblast. As you can see, they're going to be alongside the cytotrophoblast on top of it. Now they're going to be involved with placental formation. The endometrium during placental formation, these cells produce the hormone human chorionic gonadotropin HCG, which is what is tested for during a pregnancy test. So this, about day 14, you can actually detect it 20 days after menstruation, 20 days of pregnancy, day 14 of pregnancy, 28 days of cycle. When a woman starts to menstruate, she can actually begin to take HCG in her urine during the basis of a pregnancy test. Because what happens is there are going to become cavities that will form in these areas called the lacunae, and they're going to communicate the blood from the embryo to the mother so that HCG will get in. So it will take about 28 days of the cycle after the last menstruation or 14th day of pregnancy before she actually will notice that she's pregnant. So she's been 2 weeks pregnant before she can actually begin to tell. Also the we're going to get into some other cells here in a minute that we'll talk about later on, like the hyphoblast and things like that, that makes the inner cell mass become some other cells that we're going to talk about the hyphoblasts in just a minute. So the hypoblast cells, they're going to line the yolk sac. So let's go ahead and do label some other things here, and we're going to label the yolk sac, or primary yolk sac. So the primary yolk sac being here, so that makes these cells here the hypoblastic cells. Hypoblast. So those are the hypoblastic cells. And the cells that were going to line part of this cavity here, this cavity is the amniotic cavity. As we said, we're going to help understand the formation of some membranes later on. That amniotic cavity, that was covered up by the epiblastic cells, the epiblast. As we said, it would take us some time here. Now, the hypoblastic cells lining that, the hypoblastic cells will form what's called an extracelomic membrane. Your extracelomic membrane will come, a new population of cells between that to form that what we referred to as the mesodermic cells, extraembryonic mesoderm, that we're going to label now. The extraembryonic mesoderm that's formed here, that's extraembryonic mesoderm, and that's important developmental tissues. And these cells in the extraembryonic mesoderm, they're going to have spaces that are going to form into that. So we formed a lot of things here in this drawing, a lot of very busy stuff. Now, we also want to look a little bit about some more development that happens, especially the lacunae that form that release HCG. So for this drawing, we're just going to forgo the syncytial trophoblastic cells, and we're just basically, when we draw out our cytotrophoblasts, we're going to draw it a little bit more simple now, and we're just going to draw 2 rings, and we're going to make, now remember, these cells are all single nucleated cells, so we're only going to draw 1 nuclei in them, and we're going to draw these guys just all around. This is about the easiest way to do it now, since we've done it, we have an understanding of these cells, and since they are compacted, things have undergone compaction. And I'm going to put the single nuclei in them. So we have a single ring of outer cells, the cytotrophoblast. So cytotrophoblast. Okay. And then inside that, we'll draw a ring here with our extraembryonic mesoderm. And what we want to make sure we do is draw some chambers scattered hither and yon here, some bigger, some smaller chambers that are going to be the lacuna. Now, we'll try to shade this in a little bit as we go. Just can be difficult to shade all that in on the iPad that I use to make my videos, but it works good for me for the most part. So our extraembryonic mesoderm or mesoderm here, extraembryonic mesoderm has lacunae that make the HCG and get it into the bloodstream. This is how it gets in the bloodstream anyway, from the syncytial trophoblast. That's how we get the HCG into the female's blood. Now, also remember we have our cells here that are going to be covering this, the extraembryonic membrane, which we should have labeled in our last drawing, and we did not. I think I forgot to do that there, so we'll do it now. So these cells are called the extraembryonic membrane. All right, now we also have to get these two layers here of cells, the hypoblast. Here are hypoblast, and the columnar cells on top of it, which I'm going to use red for again, is the epiblast. Because the epiblastic cells here being columnar in shape, they are quite important cells used for a variety of things. So, and we're going to talk about that later on. So the what we want to make sure we do is, so we have gone with those inner cell mass we talked about before. What we want to do is have those guys alter a little bit more as well. So we're going to do one more drawing here and form what is called a bilaminar disc. So let's squeeze this in. Not as much as I wanted to squeeze that in there. We're going to give a little bit more room here on our drawing, and I'm going to squeeze this in just a little closer this time and try my best to do this smooth and quick to not waste your time. And we'll forego putting the nuclei in to get some things done there, just for time of the video, since I'm doing this live, or at least in real time. And the cells that we also saw, that we talked about, those extracelomic membranes. We talked about something called the extracelomic membrane, and we want to take a look at that. So all these outer cells that will be on the outside, we're going to take a look at them in this way, and we're going to draw a mass of cells all around here. And we're leaving out some other details right now, but we want to draw a mass of cells that go around like this. And then right here, we're going to use a dark blue. Here, that should be a dark blue, sorry, here and here. And then we're going to come back and use normal blue up here. Now, from the dark blue, we want to take that dark blue cell right here, and we're going to draw our hypoblast. They should be connected a little better than I've got them looking. And we're going to draw our columnar cells on top of that. Now this section right here will become very important in the next video. This being our amniotic cavity. This being the primary yolk sac. And the primary yolk sac, remember, you have your hypoblast and your epiblast that is separating those things here. What we now have is fully a bilaminar embryo, the bilaminar disc. And the embryo being surrounded by the cells here. So we're going to label our cytotrophoblast. And we also want to make sure we have our extracelomic membrane. Extracelomic membrane. Sorry for the writing there, it's kind of hard to write. So what we will do is we will pick up here in our very next video and discuss how this becomes how it will fold as we go through gastrulation. But this concludes my video on the basics of looking at first 4 weeks blastocyst formation and implantation. And we will pick up with gastrulation in the next video and look at body folding in a third video. So thank you so much for watching. I hope you enjoy it. Please let me know in the comments what you'd like to see in future videos. Don't forget to comment, like, and subscribe. And always, thanks for watching. Thank you so much.